Yes, let's take a look at the problem on the board. We are asked to find the adjoint of this matrix. Now, for us to find the adjoint of a matrix, we need to have what we call the cofactor of this matrix. Okay? By obtaining the cofactor of this matrix, then transposing the cofactor gives us the adjoint of the matrix. Okay? Now, let's take a look at this matrix. For us to find the cofactors, let us know that this first matrix is in the first column, first row, first column. So we can have each of the matrix of this one. A11, A12, A23, sorry, A13, sorry. Then this will become A21, A22, A23. Then finally, this will become A31, A32, A33. Okay, so A11 is the first element here, A12 is the second element, and so on and so forth. To find the cofactor of this matrix, we assign a positive, negative, positive, negative, positive, negative, positive, negative, positive numbers to each of these elements, and we now find the cofactor of the matrix. Now, what we need to do, if you are considering the first, now let us take the first element. Okay, the first is 2, 3, 2, 6, 4, 1, 2, 3, 5. Okay, now this is positive. So if you are considering this element, all these crosses out, we are left with a 2 by 2 matrix. In this case, we are not considering, unlike determinant, we are not considering these two here. Okay, we are only considering this 2 by 2 matrix. So we are going to have something like this: 4 times 5 minus 3 times 1. Okay, 4 times 5 minus 3 times 1 will give us something like 20 minus 3, this is equals 17. Okay, we are done with that. Now we go to the second matrix. We go to the second element: 2, 3, 2, 6, 4, 1, 2, 3, 5. We are considering, if you are considering the second element, know that this one is positive, this one is negative. So all the element under it has to be crossed out, then the one by it crossed out. Okay, the one on the same row crossed out. Now we are also left with what? A 2 by 2 matrix: 6, 2.